Alright, so in the second part of this video, basically it's just more examples. So I have a polynomial function I'm going to do the first derivative test with and find the min and maxes. There's a rational function, a square root function, and another rational function. And like I said, if you want to watch one and try one and then come back to the video, or watch them all, take notes, however you want to do it. It's kind of up to you. Learn it your own way. So I copied these directions. This is the assignment that you're going to do has these directions. So it's we're going to just go through these steps. So the first thing it says for this function, you know it's polynomial, so the domain is all reals. It says find the critical points. So to do that, I'm going to take the derivative of the function, which gives me 6x squared plus 6x minus 12. And I'm going to set that equal to 0 to find my critical points. The first thing I notice is that I can divide everything by 6. So I can just rewrite this as x squared plus x minus 2 equals 0. And this one, to find the critical points, I'm going to need to factor. So I'd get x plus 2 and x minus 1 are my factors of this quadratic. So my critical points would be when x is negative 2 and positive 1. So that's the first thing. Now the intervals where it's increasing, they should say decreasing. I don't know why I have increasing twice. They should say decreasing. So where is it increasing and decreasing? To do that, I kind of make a little table again, and remember our endpoints for this are going to be negative infinity to positive infinity. So I'm going to have from negative infinity to negative 2, that's my first interval, and I use parentheses because we don't really include those numbers in there. My second interval would go from negative 2 to positive 1, and my third interval would go from positive 1 to positive infinity. And in order to find where it's increasing and decreasing and the min and maxes, we need to pick a test point on the interval. So on this interval, let's say negative 3. Sorry, I don't know what that little thing is there. Negative 3. This one 0 would be a good test point, and here's 2. So these are called the test points. And remember, test points get plugged into the derivative because it tells us whether a function's increasing or decreasing. So I'm going to plug negative 3 into this derivative. So that's going to give me a positive 9 minus 3, which would give me 6, minus 2, which would give me 4. So this one is positive 4. So that means my function is increasing or going up. If I plug 0 in, I get 0 plus 0 minus 2, so that gives me a negative value, which means my function is decreasing. And then if I plug 2 in, I get 4 plus 2, which is 6, minus 2, which is 4, so it's positive, which means my function is increasing. Now, we need to analyze what we found. So I know that on this continuous function, my graph goes from increasing to decreasing. So that tells me right here, when x is negative 2, there's a maximum. So that's a max. And then my function is decreasing to increasing. So at 1, there's a minimum. And to get the y values of those maximum and minimums are the function values. You could call them the function values. You need to plug them back into the original. So I'm going to put negative 2 in there. So I get 2 times negative 2 cubed plus 3 times negative 2 squared minus 12 times negative 2. That's negative 8. So that's negative 16 plus positive 12 plus 24. So that gives me negative 4. It looks like it gives me positive 20. And check my calculations because I did not use a calculator. The next one is 1. So that's going to give me 2 plus 3 minus 12. So 2 plus 3 is 5 minus 12 is negative 7. So those are my min and my max. And then so my intervals where it's increasing, if you wanted to make a list, and sometimes that's nice, you can do that. You could say my function is increasing on negative infinity to negative 2 and positive 1 to infinity, and it's decreasing on negative 2 to positive 1, and here's my maximum and my minimum of my function. So this is really where you analyze. We haven't sketched the curve, we're just analyzing it. All right, so let's look at another example. This one is a rational function because you have 1 over x. So the first thing that I see here, and I'm hoping you start to see, is that x cannot equal 0. There's a vertical asymptote at 0 is what I'm saying. So that's going to be one of our critical points, and you're going to see that in a second. So first thing I'm going to do is find my critical points, take my derivative. So the derivative of x is 1. The derivative of 1 over x, so remember that's the same as x to the negative 1. So it's negative 1 over x squared. So if you're not sure how I did that, ask around. Remember the negative 1 comes in front, and that'd be negative 2, move it to the bottom. So this is my derivative, and I want to set it equal to 0. Just because I'm going to follow kind of how the book solves these, so what I'm going to do is I'm going to use the butterfly method on this. I'm going to make this x squared minus 1 all over x squared equals 0. Just so it looks like the answers that you would see in the book. My critical points right away, I know x equals 0 is one critical point, and I know that because 0 cannot be in the denominator. After I do that, I'm just going to pretend like this is over 1 and cross multiply, so I get x squared minus 1 equals 0. So x squared equals 1. So x would be plus or minus 1. And I get both of those because I took the square root, so I need the positive and the negative. So now we know that we have our vertical asymptote taken care of because we have that 0 there. So when I write my intervals, I still can start at negative infinity, and then I go to negative 1. And my next interval would go from negative 1 to 0. My next one would go from 0 to 1. And my last one would go from 1 to infinity. So there's 4 intervals on this one. Now you get your test point. So here I'll put in negative 2, negative 0.5, positive 0.5, and 2. And you can put it into whatever version of the derivative that you want. So here's a version. The other version of the derivative was just 1 minus 1 over x squared. So if I put negative 2 in here, when I square negative 2, that's positive 4. So I get 1 minus 1/4. So that's positive. So that means this function is increasing. And then I'm going to put in negative 0.5 for that one. So I'd have 1 minus 1 over negative 0.5 squared. So first of all, I know that's going to be positive, so it's going to be 1 minus 1 over positive 0.25. And that is going to be negative because this is 1/4. You can put it in your calculator, but I'm sure that's negative. So that's decreasing. 0.5, if I put 0.5 in, so take time, hit pause, put it in your calculator, that's actually going to give me the same value. So it's also going to be decreasing, and that's okay. And then if I put 2 in, that's going to give me this 1 minus 1/4 again. So when you put that in your calculator, it's going to be a positive 3/4, so it's increasing. So what that's telling us when we analyze is right here my function is continuous and it went from increasing to decreasing. So there's a maximum at negative 1. Here it just went decreasing to decreasing. So really there's nothing there. And actually I know that there's a vertical asymptote at 0, so that makes sense to me that there would not be a change in direction of the graph. Then the next one that I see, we should have a minimum because we went from decreasing to increasing at x is positive 1. And then if I look at my original function to find my y values, it's right there. So if I put negative 1 in, I get negative 1 plus 1 divided by negative 1. So that'd be negative 2. If I put positive 1 in, I get 1 plus 1, so it'd be positive 2. So when you analyze this, your function is increasing on this interval and this interval. So from negative infinity to negative 1 and 1 to infinity, it's decreasing on these two intervals. And I'm going to pull up Desmos just so you can kind of see what this graph looks like. And we can talk about where it's increasing and decreasing. So if you notice, our function was increasing. Here's our maximum. Or I'm sorry. Yes, our maximum at negative 1, negative 2. And then it was decreasing. Then after the vertical asymptote, it was decreasing until here. There's our minimum. And here. Now it is weird to think of a maximum actually being lower than a minimum, but remember we called them relative maximum. So this is a relative maximum and a relative minimum in that area. Alright, so let's look at another type of function here. Okay, the square root function, this one is special because of its domain. So on a square root function, remember they kind of look like that. Here, there's certain values. You need to make sure you check your domain. This could be anything because it's just x. But if I get a number bigger than 3, so like if I put 4 in here, I get an imaginary number because 4 squared is 16. 9 minus 16 is a negative value, so I get an imaginary number. So this one we have to be really careful. We need to kind of think about the domain before we actually do anything else. So the domain of this would have to go between negative 3 and positive 3. So what that means is those are actually going to be our endpoints of our graph. And I'm going to graph this on Desmos so you can kind of see what it looks like. It was x times the square root of 9 minus x squared. So that's what the graph is going to look like. So remember my domain went from negative 3 to 3 because anything else would give me an imaginary number. In calculus, we don't care about imaginary numbers. We pretend they don't exist. So let's go back and look at how we solved this. So really this domain, instead of having negative infinity to positive infinity, we're going to use these as our endpoints. So first thing we're going to do on this one, and this is kind of a tough problem, we're going to take the derivative. And in order to take the derivative, I need to use the product rule. So I take the derivative of the first, which is just 1. So I have square root of 9 minus x squared. Plus I keep the first, and the derivative of this. So the derivative of that is going to be 1/2 times 9 minus x squared to the negative 1/2 times negative 2x. So it's a chain rule. So my first term just looks like this. My second term, if you notice, this 2 will cancel with this one. So I'm left with negative x squared in the numerator all over the square root of 9 minus x squared because I brought this negative down. So that's my derivative. If I do the butterfly method on this, well, you know what, let's not do the butterfly method on this one. So I'm going to set this equal to 0. So right away, because we're in this domain, I see that there's something in the denominator, but I think we're going to be okay because we already took care of the domain. And so anything in that domain works. So we don't have to worry, even though there's something in the denominator, we don't have to worry because everything between negative 3 and 3 will work in that function. So without doing the butterfly method, how I would solve this is I would probably just leave this one here and move this squared term over to make it positive to the other side. And then cross multiply, we've been doing that a lot. So I get 9 equals 2x squared. So 9 over 2 equals x squared. So that's going to be the square root. So it's going to be plus or minus. The square root of 9 is 3 over the square root of 2. And I'm going to leave my answers like that. Remember, I don't care if you have a square root in the denominator. So my intervals are going to go from -3 to negative root 3 over 2. No. -3 over root 2. And then the next one's going to go from -3 over root 2 to +3 over root 2. And then the last one's going to go +3 root 2 to +3. So you're going to use those intervals. So like a test point in here, well, this one I know could be 0. This one we could do, if we use a calculator, this doesn't always work so well for me on here. Let's see, -3 divided by 2 square root is -2.21. So I'm going to just say we could use like -2.5 here. That means we could use +2.5 here. And then you're going to put those in your calculator to figure out if, into your derivative here, to figure out if they are positive or negative. So I'm going to give you a second to put those in there and figure out if they're positive or negative. All right, so you hopefully got negative, positive, negative. And then you know that you would have if you go from decreasing, so this is decreasing, to increasing, so there's a minimum at this -3 over square root of 2. It's like -2.1 or something like that in your calculator. And then you went from increasing to decreasing, so there's a maximum at +3 over square root of 2. And now you're going to put those back into this function up here to find the y values, which I'm going to have you hit pause and get those y values. Okay, so this you get -4.5, and this one you get +4.5. So I will tell you that is a pretty difficult problem. I actually have one more problem I want to go through. And like I said, if you think you have enough, or hit pause and come back to this one later, but make sure you watch them. This one is a rational function. So when I look at this, I see vertical asymptotes at x equals 3 and -3 right here. So we need to make sure when we do our intervals that we have those, which I think we'll find them in our derivative, but let's just make sure. So our derivative, we're going to use the quotient rule, so it'd be 2x times x squared minus 9 minus x squared times 2x all over x squared minus 9 squared. Simplify the numerator. This would give me 2x cubed minus 18x minus 2x cubed, which worked out really great because these are now going to cancel. So I get negative 18x all over x squared minus 9 squared. That's my derivative. I set it equal to 0. Again, I see two critical points at 3 and -3 because of my denominator cannot be 0. So then if I do my cross multiplying, I'm going to end up with negative 18x equals 0. And solving that means there's another critical point at 0. So 3 critical points. Not saying that the direction's going to change, but those are 3 things I need to check. So rational functions, except for these 2 points, which I already have, are continuous. So I'm going to start at -infinity. I'm going to go to -3. I'm going to go from -3 to 0, and then 0 to 3, and 3 to infinity. Put in -4, -1, 1, 4. Those are my test points. I'm going to put them in, test points go into the derivative, which is going to be right here. So you can use your calculator or just kind of think them through. I'm going to hit pause again and let you use your calculator and find those. Okay, so I know that this one is increasing because this is going to be a positive and a positive. This one is also increasing because this is where the vertical asymptote is. If I put 1 in here, I'm going to get a negative value, and a squared is always positive, so that's going to be decreasing. And if I put 4 in there, I'm going to get a negative over a positive, so it's going to be negative. So this one is decreasing. So here, I know that this is a vertical asymptote. And at 3, I also know that's a vertical asymptote. So it looks like I have a piece of my function that goes from increasing to decreasing. So I have a maximum when x is 0. And to get that y value, I would plug it in here. So 0 over negative 9 is 0. So I have 2 intervals where my function is increasing, 2 where it's decreasing, 1 maximum, and 2 vertical asymptotes. And again, eventually we're going to sketch these, but what I like after you get your answers today, or even if you get stuck, plug them in Desmos or your graphing calculator. So if I plug this into Desmos, not like that, x squared minus 9, you can see my function is increasing. Wait, let's go back. Yep, increasing. It's increasing here. It's increasing here. This is a maximum. Then it's decreasing, and then it's decreasing. And here are those vertical asymptotes that we don't see when we graph it on Desmos. All right, so I know a super long video, but like I said, you can watch it again. You can do some problems. Your homework is a Word document. Just put it in your notes. Make sure you understand the steps that you're doing here and what those things mean, like what a vertical asymptote means, what a max and a min mean. Have a good day.